All right. Example 22 is asking if y is equal to 2x squared plus 3x minus 1, where to identify the domain and the range of y. And then it asks, does the inverse of y exist? Now, for a quadratic function, in order for you to identify the range, well, the domain for a quadratic function is usually x, which is an element of the set of real number, all real numbers. So I can start out by saying what the domain is. The domain is essentially x is an element of the set of real numbers. So all real numbers. All right. The codomain, again, would be also all real numbers, but they didn't ask for the codomain, they asked for the range. To answer the question of the range, I need to know the coordinates of the minimum turning point. To know the coordinates of the minimum turning point, I'm going to have to complete the square. All right, so let's do that. Let's factor out a 2. So we have 2x squared plus 3 over 2 x minus 1. We have 2 x squared plus, I factored out a 2 times 3 over 4 x. All I did there was multiply. Well, this is something you should know. I multiply and divide by 2. Then I'm going to have 2 x squared plus 2 3 over 4 x plus the square of 3 over 4, which is 9 over 16, minus 9 over 16. I added and subtracted 9 over 16 minus 1. So now I have 2 into x plus 3 over 4 square minus 9 over 16. Minus 1. Remove the bracket, the outer bracket. We have 2x plus 3 over 2 square minus 9 over 8. Minus 1, which could be written as 8 over 8. So what I have is that y is actually equal to 2 into x plus 3 over 2 square minus 17 over 8. What else? So this would be in the form a into x plus h square plus k. And minus hk would be my turning point. Minus hk would be my turning point. And so k, so in other words, my graph would probably look something like this. Not the best. Let me just try and see if I can do better. It's a parabola. And this is the minimum turning point, which would be minus 3/4, which is minus hk, which is minus 17 over 8. That's my turning point. All right. What else? So let us say this could be a y-axis and this could be a x-axis. So my graph could look something like this. All right, so what would be the range? Remember, the range would be the values of y where the graph what exists. So the range would be y is greater than or equal to minus 17 over 8 or minus 2 and 1/8. That would be the range. Y is greater than or equal to minus 2 and 1/8 because the graph only exists above the minimum turning point. So the range would be values of y above the minimum turning point. All right, so that's the range. The last part of the question, does the inverse of y exist? The answer is no. The inverse of y does not exist. Why is that so? Essentially, that is because y is not what? Bijective. If you draw a line parallel to the x-axis above the minimum turning point, it will cut the graph what? 2 times. Therefore, that would mean that the graph is not what? Injective. Because for it to be injective, it has to cut it at most what? Once. And every line drawn parallel to the x-axis above the minimum turning point will cut the graph twice. Therefore, it is not injective. If you draw a line parallel to the x-axis below the minimum turning point, it will not cut the graph at all. So therefore, that means it is not what? Surjective. Because in order for it to be surjective, every line that can be drawn parallel to the x-axis must cut the graph at least once. So it's neither injective nor surjective. Therefore, it is not bijective. And if it is not bijective, it does not have an inverse. All right, example 23. Now, example 23 says a function f is defined by f of x is equal to x squared minus 2x plus 3. We're asked to, and we're told that x is an element of the set of real numbers, and the domain is further limited by the fact that x must be greater than or equal to minus 1. Remember, the only way a quadratic function will have an inverse is if the function is limited to half, only part of the domain is limited to only half of where half of the graph exists. That's how I could say it. All right, so the first thing I asked to do is to write f of x in the form a into x plus b squared plus c. In other words, we're asked to complete the square. There are several ways in which this can be done. I could use the formula approach. I could say h is equal to b over 2a, because I need h, because minus h is the value of x at the turning point. So h would be minus b, which would be minus 2 over 2a, which is 2 times 1. Minus minus is plus, so this is 2 over 2. H is equal to what? 1. And k, as I've told you before, is equal to f of minus h, which is equal to f of minus 1. So this is another way in which you can determine what h and k is. All right, so K would be equal to f of minus 1, which would be minus 1 square minus 2 times minus 1 plus 3. This would be 1 plus 2 plus 3. K appears to be 6. So minus, something seems wrong. Minus is, sorry. Yeah, something seems wrong from up here. All right. Some up here, something is wrong. I'll just fix that quickly. H is equal to B over 2A, not minus B. It's equal to B over 2A. So it's minus 2 over 2 times 1, which is minus 2 over what? 2, which is equal to minus 1. K is equal to F of minus H, which would be equal to F of 1. Because if H is minus 1, minus H would be minus minus 1, which is 1. So K would be equal to 1 square minus 2 times 1 plus 3. This is 1 minus 2 plus 3. This is 4 minus 2, which is 2. So 1, 2 is the turning point. So therefore, I have H and I have K. Therefore, f of x is actually A, which is 1, x plus H, which is what? Minus 1. So we wouldn't say plus H, would just be minus. It would be just minus 1. Plus H is plus minus 1, which is minus 1. Square plus K, which is what? 2. So essentially, this is x minus 1 square plus 2. We got it in that form. Next thing we're asked to hence find the range and the inverse. Well, remember your quadratic function. This particular quadratic function looks like this. This line is x is equal to 1. All right, let us say that this is my y-axis, x-axis. This is the y-axis. If here is 2, the graph starts here and actually goes up like this. That is an idea of what the graph would look like. This is only half of the graph. Because remember, you are told that the domain, the graph only exists where x is greater than or equal to 1. That is what we were told. 1, 2 is the turning point. So this graph starts from the lowest point of the graph, and it is only the right half of the graph. The function is only the right half of the quadratic function. This is f of x is equal to x squared minus 2x plus 3, where x is greater than or equal to 1, and x is an element of the set of real numbers. That is the graph that we have. Clearly, this has an inverse. It has an inverse because it is both injective and what? Surjective. So it has an inverse. We're asked for the range, so let's answer A. A, the range, values of y where the graph exists, is y is greater than or equal to 2. and the domain is x is greater than or equal to 1. Now this is important because when you find the inverse, the domain and the range are going to interchange. Next, we're asked to find the inverse of f of x. Well, we can do that by calculation. F of x is equal to x minus 1 square plus 2. That is it. This is the function in completing the square form. Y is equal to x minus 1 square plus 2. Let's interchange. X is equal to y minus 1 square plus 2. Let's make step 3 is to make y the subject. So we have x minus 2 is equal to y minus 1 square. The opposite of square is square root. So y minus 1 is equal to the square root of x minus 2. And so y is actually equal to 1 plus or minus the root of the square root of x minus 2. So my final step is to say, all right, first of all, remember, all right, my final step is to say f inverse of x would be equal to 1 plus or minus x minus 2. That's the inverse of the function. But please remember, the inverse of a quadratic function does not exist unless you limit. It only exists for a specific range and a specific domain. So for f of x, the domain is going to be x is greater than or equal to 2, and the range is y is greater than or equal to 1. You might ask, how did I get those so quick? It's coming from this. When you find the inverse of a function, the domain and the range values interchange. The range of f of x is y is greater than or equal to 2. The domain of f inverse x is greater than or equal to 2. The domain and the range values interchange. Ladies, gentlemen, you can ask me about this afterwards. So this is the answer for C. And because of that, now with that knowledge, I'm going to change the answer for B to say f inverse of x is equal to 1 plus the root of x minus 2. And the basic reason for that is the range. You're told that the range of f of x must be greater than or equal to 1. If there was a negative there, if it was minus the root of x minus 2, you would see, if let us say x was 6, if x was 6, you'd get what? 6 minus 2 is 4. The square root of 4 would be 2. It would be 1 minus 2, which is minus 1. But f of x cannot be minus 1. The lowest value of f of x is, of f inverse of x is 1, because the range is greater than or equal to 1. With that in mind, f inverse of x is 1 plus the square root of x minus 2.